Hi, everyone. So I'm just going to work out a few of the more difficult problems from the review for test two. And so let's jump in with this one. According to modern science, Earth is about 4.5 billion years old. Oh, wait a second here. You see the number 9 up here in the upper left? So for each of these questions, I have written down the question number that they are in the assignment. All right, in the review assignment. I'm actually doing them in order for what MyLabs Plus says is hardest question down. All right, but so I've written the question number if you want to go to your question in MyLabs Plus. Yours probably doesn't have these exact same numbers in it, but it'll be the same question otherwise. All right, so according to modern science, Earth is about 4.5 billion years old, and written human history extends back about 10,000 years. Suppose the entire history of Earth is represented with a 1,000-meter long timeline, with the birth of Earth on one end and today at the other end. What distance represents 4.5 billion or 4 billion years? All right, so thinking about this is take the data they've given us as a conversion factor, all right? So 4.5 billion years per 1,000 meters, all right? So I'm going to think of my conversion factor since they're asking us questions about how long stuff is, right? I'm going to think of it as 1,000 meters per 4.5 billion. So I'm just going to write it with a capital B for now. When we get into the calculation, we may have to actually write out all the zeros. All right, so first is what distance represents 4 billion? All right, years. So 4 billion. All right, yeah, we're going to have to write the zeros. 4, that looks like 4 million right there, right? And billion is the next level up, so 3 more zeros. All right, so what it is, we got 4 billion years, and we want to convert it. We can use our conversion factor here. Years, 1,000 meters over 4.5 billion. So 4, 5, 0, 0, 0, 0, 0, 0, 0, 0 years. All right. This is the A question here. So I just got this 4 billion years from this. See, the years are going to cancel. We're going to get meters. And if you multiply this out, just like the answer says up there to one decimal spot, you will get 888.9 meters. All right. And then B, human history begins, how far from the end? Well, human history, they tell us human history is 10,000 years. So what we really need to do is take the 10,000 and we're going to apply and we're going to convert it, right? So we're starting with 10,000 years. We've got 1,000 meters, right, over our 4.5 billion years. Right? So we've canceled out the years, right? Years and years. Now we're in meters. We need to get to millimeters. How many, right? So we've got to cancel out the meters, so they'll be in the denominator. Millimeters will be in the numerator. How many millimeters in a meter? All right, well, this is one of the ones we're supposed to memorize. I think it's on the chart too, 1,000 like that. Okay, so you put this into your calculator, and in the top here, so it's 10,000 times 1,000 times 1,000. All right, so to the numerator, 10,000 times 1,000 times 1,000 divided by this 4.5 billion, and what you are going to get then is 2.22. It's actually 2.2, and then the 2's are running off the screen. All right, so that's one. All right, so here, let's do the next question. All right, use sample currency exchange rates given in the table To answer the following question, state all of the conversion factors that you use. Suppose that a new fuel-efficient European car travels an average of 26 kilometers on 1 liter of gasoline. If gasoline costs $1.25 per liter, how much will it cost to drive 250 kilometers? So there's a couple things going on here. At the end, they're asking us for the number, and then they're going to ask us to pick all the conversion factors we use that were part of it. All right. So, all right, how much will it cost to drive 250 kilometers? So what that's happening here, right? How much will it cost in dollars? So what that means is we start with 250 kilometers. That's how far we're going to drive. And over here, we want to end up in dollars. Okay. All right. So the first thing we've got here is we've got, see, we have 26 kilometers for 1 liter. All right. Well, so let's go ahead and convert it to the amount of gasoline. So I have 1 liter over 26 kilometers. Right. So the kilometers are done. I've got liters, and they tell us that 1 liter costs 1.25 euros. All right. So 1.25, I'm going to use a capital E as the abbreviation for euros, over my 1 liter. Okay, all right, so I'm just using the ones they give me. All right, and now the liters are gone and I'm into euros, right? And I'm almost there, right? Remember, euros are money and I need dollars. So I come over here to the table, a European euro, dollars per foreign. So this means it's $1.256 per euro, right? And I got to get out of euros, right? And into dollars, okay? So since it's dollars over euros, that is dollars per euro. So 1 euro is $1.256. And if you'll notice, these 3 conversion factors we used are the 3 that are highlighted in the answers here, right? Right? And you multiply this out, right? So I would do 250. So times 1, you don't need to, times 1.25 times 1.256. Divided by 26 is going to equal, actually on my calculator I get 15.096, and since it's money that rounds to $15.10, which is their answer. All right, there's another one. All right, let's look at the next one. So now this one is number 41 in the review assignment. Okay, now this is one of these frequency tables, okay? In a lot of ways, this was mostly about just remembering what the definitions are. Right? So let's look at the frequency column first. They're nice on this one in that they sorted them in order, right? So there's my A's, there's 3 A's, there's 3 A's. There's my B's. Counting that up, there's 8 B's. There's 8 B's. Count the C's. 1, 2, 3, 4, 5, 6, 7 C's. Right. 1, 2, 3, 4, 5 D's. And then 1 F, right? All right, so just count those up. Add those up, there's 24 total. Now the relative frequency, what you do is you take the count for the class divided by the total count. So in other words, 3 divided by the 24 will get you 0.125, and then turn it into a percent gets you 12.5%, right? Let's skip down to, so for B, for example, there's 8, the total is 24. 8 divided by 24 gets you 0.333, actually gets you 3's running off the screen. Turn it into a percent, you know, move the decimal place 2, it's 33.3. All right, so that's the first 2 columns. Now the last column, you got to remember, is the cumulative frequency. So what it is the frequency for that row plus all the ones before it. Well, in the first row, there's nothing before it, so the cumulative frequency matches the frequency. Second row, it's the frequency of that row, 8, plus the ones before it. Well, the ones before it was 3. 8 plus 3 is 11. Third row, the one for that row is 7, right? Plus, and then the ones before it, just add the number above there in the cumulative. 7 plus 11 gets you 18, right? Fourth row, cumulative, right? The one for this row is 5, plus the 18 from the ones before gets you 23. And that is how those work. Like I said, this is mostly about remembering these definitions. All right, let's look at the next one. This one's number 40. It's right next to the one we were just doing. I'll give you a moment to get there. Okay. So this one is kind of really about using our definitions and thinking to answer some questions. Okay. So for the most common salary, well, the most common is always the mode. That's what mode means. That's why this is 730, right? 730, 730. The salary that half the employees surpass. All right. Well, half surpass, right? That's kind of the midpoint. There's two ways to look at that. The half surpass would be the median, 675, right? See how it matches. You could also call that Q2 if they did this differently, because remember Q2 is the median. Both cases, that's the 50th percentile. All right. Now, the percent of employees that surpass 795. Well, if you look up here, now they're doing it differently. I gotta find, here's the 795. That's the third quartile. Well, the third quartile is the 75th percentile, right? 75th percentile. All right. So that means this is higher than 75% of the numbers. Well, this says what percentage surpass it. So if this is higher than 75%, that means it's lower than the top 25%, right? You with me? So this one is 75th percentile, so it's higher than 75%, so it means it's lower than 25%. That's where the 25 comes from. Okay. All right. Less than 430. We come up here, 430 is the first quartile, right? It's the first quartile, so it's higher than the 25%, which is really the same way of saying that 25% are less than that. See, what they're doing here is they're flipping the words around. They're making us think a little bit about what the words mean. Percent of employees that surpassed 814. Well, 814 is the 81st percentile, right? 814 is greater than 81%, right, of the data. So that means that leaves me 100 minus 81 is that leaves me 19%. Is that bigger? And then that gives me this number. You with me? All right. So if the company has 100 employees, what's the total salary? Well, to do that, we're going to have to do the mean. All right. So $645 per employee. All right. And 100 times 100 employees is going to get me 64,500. All right. So that's the end of that one.